Welcome back to another Forge College Explainer. Seriously, I am absolutely thrilled to have you here today. So, in our last module, we tackled mapping out the transition of ERC-20s and ERC-3643 security tokens to Solana's SPL tokens. We dug into supply constraints, mint authorities, all that good stuff. Well, today, we're taking everything you know about EVM NFTs, specifically the ERC-21 standard, and translating it directly into Solana's modular architecture using Metaplex. We are going to map out ownership, metadata, and provenance so your capstone project is structurally sound and, ready for deployment without catching on fire.
To really kick things off, we need to answer a pretty fundamental question. Where exactly do your NFTs actually live? Think about Ethereum for a second. It's kind of like this massive, old, overstuffed filing cabinet. Every single NFT in a collection is just jammed into one giant smart contract that tracks all the token IDs, the owners, and the URIs. It's a bit dusty, highly prone to paper cuts, but hey, it works. Solana, on the other hand, it's like a hyper-efficient, highly segmented modern patent office. Instead of one giant ledger, Solana gives every single asset its own dedicated desk, its own folder, and its own receipt. Wrapping your head around this bureaucratic shift is absolutely crucial to mastering Solana development. Okay, here's our game plan for today. 6 quick steps. First, the foundational shift from EVM to Solana. Second, Metaplex metadata mechanics. Third, certificates, folders, and receipts. Fourth, we'll apply this to our capstone collection, Forge Flora. Fifth, we'll cover the economics, storage and royalties. And finally, getting all these artifacts ready for your devnet deployment.
Let's dive right into Section 1, EVM to Solana, the foundation shift.
You might be wondering, why are we obsessing over designing this schema right now? Because doing this groundwork today prevents massive tear-your-hair-out headaches when you actually deploy to devnet later. There's a really stark contrast in architecture here. Like we said, Ethereum uses that single contract as a master ledger, but Solana, it breaks the whole thing down into 3 distinct parts: the mint public key, the token account, and the metadata account. On Solana, ownership isn't just a database entry mapped to a token ID. Ownership is literally a token account balance concept. You hold a balance of exactly 1 in your specific token account. It's modular, it's isolated, and man, is it incredibly fast.
Moving right along to Section 2, Metaplex mechanics and metadata on Solana.
So now that we know Solana splits the token from its actual data, how do we attach an image to it? That is exactly where Metaplex comes in. It's the standard protocol that programmatically attaches a metadata account directly to your token's mint. Look at how these EVM concepts map one-to-one. Your ERC-721 token ID, that becomes the mint pubkey on Solana. The ownerOf function translates directly to the owner of the associated token account. Your tokenURI maps right over to the URI field inside the Metaplex metadata account. And as for your ERC-2981 royalties, well, Metaplex just handles this natively with a seller_fee_basis points field and a creators array. Same core concepts, just slightly different language. Now, this brings up a concept that's totally unique to Solana, and honestly, it's brilliant. The Master Edition. If you're doing a one-of-one NFT, you just have a standard metadata account. No big deal. But if you're creating a limited print run, let's say 100 copies of the exact same artwork, Solana uses editions. The Master Edition is the canonical origin. It acts literally like the master plate in a printing press. From this master plate, individual numbered prints are derived. It's an amazing way to economize minting and perfectly track provenance without needing completely new schemas for every single copy.
All right, let's bring this down to earth in Section 3, certificates and folders. This is my absolute favorite mental model.
Look, I know terms like program-derived addresses and metadata pointers can sound incredibly dry. So, to make these abstract cryptography concepts feel like tangible paperwork, just picture an actual office desk. Step 1 is your mint authority. Think of this as the certificate. It proves the asset can be created and dictates exactly who's allowed to issue it. Step 2 is the metadata account. This is the official folder clipped right to the certificate. It holds the display name, the image pointer, your royalty splits. And finally, Step 3, the associated token account. This is the physical receipt sitting in your wallet. It proves that you, and only you, own the contents of that folder. So, to recap, the certificate proves it exists, the folder tells you what it looks like, and the receipt proves it's actually yours.
Which perfectly tees up Section 4, the Forge Flora example. Time to put theory into practice. Let's see what this builds into when we make something real. We'll use Forge Flora, our hypothetical capstone collection. Here's a peek at what the Forge Flora JSON schema looks like inside that official folder we just talked about. The name and symbol are your display fields, plain and simple. The image and external underscore URL, those are your pointers, telling the wallet exactly where to go fetch the actual artwork. Your attributes are absolutely crucial for marketplace filtering, so buyers can actually find that rare crimson flower they're looking for. Then the creators array dictates the economic splits. And finally, the collection field anchors the cryptographic provenance. It mathematically proves this item is official and not some cheap knockoff.
Next up, Section 5, Storage and Royalties. Let's talk economics.
So you've designed this amazing folder, but where does it actually sit on the internet? And more importantly, how do you get paid? Well, you've got a major trade-off to consider here. Storing data directly on-chain gives you super high permanence, but it comes at a massive financial cost and has strict size limits. I mean, you literally can't put a 4K image directly on the blockchain affordably. Off-chain storage like IPFS, on the other hand, is much cheaper and easily handles massive media files, but it relies on external hosting. So what's the best practice? Keep your critical provenance, like creator verification and collection links, firmly rooted on-chain, but let your heavy, descriptive JSON and big media files sit securely off-chain, best of both worlds.
Now, speaking of getting paid, let's talk royalties. Let's say you want a 5% secondary sale royalty. If you jump into the Metaplex metadata, you might get a little confused at first because you are not going to write the number 5. You're going to write 500. In Metaplex, percentages are always written in basis points under the seller_fee_basis points field. So 10,000 equals 100%, which means 5% is 500 basis points. It sounds like a massive number, I know, but it's really just standard financial notation to make sure we have absolute mathematical precision.
And how does that 5% actually get sliced up? Well, the creators array in your JSON dynamically routes those secondary sales. In our example here, creator 1 gets 70% and creator 2 gets 30%. But take a close look at those tags, verified versus unverified. This is a huge security feature. That cryptographic verified Boolean requires the creator's wallet to actively sign the metadata, proving they actually worked on the project. Without that verified true tag, marketplaces just won't trust the collection. It completely stops bad actors from routing royalties to random, unaffiliated wallets.
Almost at the finish line. Section 6, Preparing for DevNet. Actionable next steps. All right, we have our blueprint, and now we just need to pull it all together. Before you go mass minting anything, you really must adhere to these strict rules. First, finalize your JSON metadata schema. Double-check that every attribute and spelling is absolutely perfect. Second, make your final calls on which fields live on-chain versus off-chain. And third, absolutely ensure your mint and update authorities align with your overall governance strategy. Because remember, these artifacts aren't just theory anymore. They are the exact, literal inputs you'll be plugging into your scripts in the very next module.
So I'll leave you with this final kind of provocative thought. Is your metadata schema truly ready to withstand the DevNet test? Have you checked your basis points, verified your creators, and locked in your storage strategy? Seriously, take the time to get this right now, and your deployment is going to be an absolute breeze. Thank you so much for watching this explainer. To continue your Web3 journey and jump into the next guided build, make sure to visit forge.college. Keep building, stay curious, and I'll catch you in the next one.